Special cases or special sequences, you should be able to recognize the following pattern, that every time you see something that is not adding or not subtracting, then you should result to this. So please be very sensitive to numbers like 1, 4, 9, 16, 25, or any number plus or minus from there. It means that 0, 3, 8, 15, 24. It means that it is a square number minus by 1. Okay, this type of question won't come out. Not it won't come out, it's just that they won't ask you to figure out 2n square. They will ask you to put in the n number, but they won't ask you to figure out 2n square. Most probably. Most of the time you need to see what is it about, and then you will be able to identify. You must be sensitive to square numbers as well as cube numbers. So cube numbers should be like this: 1, 8, 27, for 64, 125, or anything plus or minus from there, which is like 0, 7, 26, 63, 124, or add from it 2, 9, 28, 65, 126. So this is n cubed plus 1. This is n cubed plus minus 1. This one just now, like I said, 0, 3, all these things is n squared minus 1 towards a certain extent. So they can use in sequences like this. If you have a fractional sequence, don't worry. The top is the top, the bottom is the bottom. So you may have two n term. N term for the top, n term for the bottom. So since it is 1, the n term for this will be 1 over n squared, because the 1 doesn't change. Okay. And then you have triangular numbers, which hardly ever happens. Then if it really does happen, then this is the one here. If it does come out, then it is your luck. That it is. This is the sequence. So they just give you the number, the n term for these type of special case or special scenario sequences. And then last, you have a Fibonacci sequence. Most probably they won't ask you to find the rule, but they will ask you to find the next two numbers. So in order to see a Fibonacci sequence is 1, 1, 2, 3. It means that the first number add the previous number. So you can see 1 plus 0 equals to 1. And then 1 plus 1 equals to 2. 1 plus 2 equals to 3. 2 plus 3 equals to 5. 5 plus 3 equals to 8. So it goes on, goes on, goes on. So it's just like this, and like this, and like this, and like this. It goes on and on and on. That's what you call a Fibonacci sequence. So after this, you should be able to figure out the sequences based on the term-to-term rule. So for example, here you can see 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 7, 12, 11, sorry. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 10, plus 4, plus 4, 4n plus 3, n term. Okay, then you should be able to figure out the sequences here, and you are very well off, good to go.